In addition reactions, two heads are better than none. Alkene addition reaction can be used to make different functional groups, such as alkyl halides, alcohols, dihalides, and halohydrins. The reaction of an alkene plus a halogen such as Br2 forms a dihalide. This is a polar reaction, so the pi bond in the alkene is the nucleophile and bromine is the electrophile. Now Br2 is nonpolar, but here's what's happening. At one instant in time, there's more electrons around one Br than the other. So the right Br has a partial negative charge, the left one has a partial positive charge. At another instant in time, the reverse is true. Averaged over time, the electron distribution around each Br is uniform, and that makes Br2 nonpolar. When the nucleophilic pi bond reacts with the electrophilic Br, a bromonium ion intermediate forms. In the reaction of an alkene plus HX, a carbocation intermediate forms. If it makes it easier for you, turn that bromonium ion intermediate into a carbocation. Then the bromide ion reacts with the carbocation to form the product. This picture shows the stereochemistry of the alkene halogenation reaction. Stop the video and determine whether the chlorines react syn or anti to each other. And the answer is, if you want the two chlorides to be syn instead of anti, use this catalyst. A bromohydrin forms when an alkene reacts with Br2 and water. Stop the video, take a look at this mechanism and answer this question. And the answer is, note that this intermediate form is followed by the product. Let's practice. Stop the video and predict the product of each reaction. And the answers are, in an alkene addition reaction, different atoms or groups can add to each vinylic carbon to form a different functional group. So we've looked at these four. This hydrogenation reaction to convert an alkene to alkane is very common. Unsaturated fats are converted to saturated fats by hydrogenation reaction. Naturally occurring unsaturated fats are cis, but this reaction also produces trans fats. So let's practice. Stop the video and draw the structure of the product of each reaction. So here are the answers. 1-butene can be used to make many different compounds. What reaction conditions would you use for each reaction? See practice problem 6b. When an alkene reacts with a peroxy acid, an epoxide forms. An epoxide can form a diol, and it can also react with a nucleophile in a substitution reaction to form one of those products. Which product do you think forms? Stop the video and think about that. And the answer is, organic chemists usually start with a small compound to make bigger compounds. But sometimes you want to make a smaller compound from a bigger one. You can use the ozonolysis reaction to do that. In the ozonolysis reaction, the carbon-carbon double bond breaks to form two carbon-oxygen double bonds. So let's practice this ozonolysis reaction. Stop the video and draw the structure of the product of each reaction. So here are the answers. 2 products are formed in the first reaction, 3 products in the second reaction. Let's apply your knowledge of reactivity principles. Stop the video, take a look at this reaction, and explain how product 1 is produced, and then draw the structure of product 2. Here are the answers. The alkene reacts with H2SO4 to form a carbocation. The carbocation is A, and the pi bond is A. So, the green line is the bond that forms between the carbocation and the alkene. The carbocation undergoes elimination to form product 1. Here's how product 2 forms. This is also an elimination reaction. Which product is more stable? Styrene is used to make polystyrene or styrofoam. This reaction is very similar to the previous slide, so stop the video and draw the structures of A and B. And the answers are, the chain grows larger with more styrene. Squalene is an alkene and is used to make cholesterol. This reaction is an addition reaction. An enzyme makes a carbocation. Then the nucleophilic pi bonds react with the electrophilic carbocation in a series of reactions to make lanosterol. Eventually, the lanosterol is converted to cholesterol.